So please continue.
Thank you, madam, for your nice introduction. Uh, I would like to welcome all of you in my presentation, which is on water and nutrient management through drip irrigation. So, you all are aware that this water and nutrients are very crucial inputs for crop production or for agriculture. So, let us take one by one. First, we would talk about water, then we go to the nutrients, and then how you can enhance the efficiency of use of these inputs in agriculture. So if you talk about water, so in our mind it is there that there is abundance in availability of water in the earth's surface. It is okay, but if you see the most of the water, more than 97% is water which is having salt and which is not suitable for utilization. Only less than 3% water, which is fresh water, is available for utilization purpose. So that is the case, and we have to think that how this a very less percentage of fresh water, how it should be utilized so that utilization efficiency should be more. Let us see the water use pattern. So if you see before 1940, there was not very rapid growth in water utilization. But after 1940, there was a huge enhancement in water use in different sectors. And you can see here from 1940 to 2000, so it has enhanced 4 or 5 times, and it will be more in future. So that is the case, means we are using more and more water in different sectors. Then let us talk about resources which are available to our country. So you all are aware that 4% of fresh water is available to our country, and we are having only 2.4% of total land, and population is about 17.7% of global population. So you can imagine that our population is very huge population, but resources as compared to population, resources are less. And this freshwater resources, which is 4% of global, is available through rainfall, and average rainfall is 1170 millimeter. Then let us talk about groundwater exploitation in our country. So here you can see entire throughout India, this western part and southern parts, where groundwater is over exploited. So these are the regions where groundwater is over exploited, and there is need to think about that how this over exploitation is checked, and what would be the means that there should not be also our agriculture should be affected. So at the same time, you have to check the over exploitation with a good agriculture production. Then let us talk about water resources of India. We have talked about that we have only 4% of water resources. So how we are getting 4% of water resources? So if you think about geographical area and average precipitation, so you can find out that how much total fresh water we are going to get on annual basis. There may be a slight change, but on an average basis, if you multiply with precipitation, average precipitation with our geographical area, then you will get total quantity of fresh water which is available annually to our country. And these are the bifurcation that whatever we are receiving the fresh water, there will be some loss of water, fresh water due to evaporation. There will be loss of fresh water due to runoff. So only thing is that we can have more water resource for utilization by reducing the losses which is occurring in evaporation and runoff. Then the same way I have told you that total precipitation which we are getting annually on average basis is 4,000 million cubic meter, and the which is utilizable is 1,086 billion cubic meter. 690 billion cubic meter from surface water and 396 billion cubic meter from groundwater. So this is the scenario, and we have to manage with this available fresh water. Our availability of fresh water is almost constant. On an average basis, it is 4,000 million cubic meter per year. But due to increase in population, our population in increasing day by day. So due to increase in population, per capita water availability in our country, in India, is reducing. And if you see, from year 1951 to 2050, so we are reaching toward the water stress condition. Water per capita water availability was very much higher in 1951, that is around 5,000 meter cube per year. But it is going to be reduced to the level of 1,140 meter cube per year in 2050. So as I have told you that this per capita water availability is reducing because of increase in population. If our population become constant, then this per capita water availability will be the constant. So it is reducing because of increase in population. So here, as I have told you that in 2050, we will be very much close to water scarcity line. This is the water scarcity line, and we are slightly higher than that. The availability of per capita availability is slightly higher than that. But after 2050, there may be that our country become water scarce country because of increase in population. If you see here, on average basis, India is under water stress condition. It is on average basis. There may be some part of country under stress condition and other part may not be under stress condition. But if you talk on average basis, per capita water availability, so it is under water stress condition. And if you talk about scarcity, so here, if you see the total geographical area of country, so western part is physically water scarce region, and eastern region or not that kind of situation is occurring, but western part is more water scarce uh, region. So what is the problem? Because in agriculture, we are using most of the fresh water in agriculture. Globally, it is 69%. So 69% of fresh water is used in agriculture sector globally. But in case of our country, in India, it is more than 80% fresh water is used in agriculture. So if water use efficiency in agriculture is less, it means that we are wasting a lot of water in agriculture. And we have already seen that this fresh water is very, very limited. We are having only 4% of fresh water which is available globally. And because of increase in population, our per capita availability of water is also reducing. So, because 80%, more than 80% water is used in agriculture sector for irrigation, so we can save a lot of water by enhancing the efficiency of irrigation system. So let us see that what is the estimation for water needs. This is the estimation for 2025 that irrigation will require about 77 million hectare meter of fresh water. And other sectors are also require fresh water. And total requirement is about 105 million hectare meter. This is the demand of fresh water in various sectors. And let us say that if we are not managing this use of fresh water with some improved management techniques, so our requirement is higher. In 2025, it is 1093 billion cubic meter. And if we manage with good practices, it will reduce to 843 billion cubic meter. So here is a scope for saving of water, and not only saving. If we will not do that, so from where we will get the fresh water for utilization? So it is not only saving. We have no other mean to get more fresh water, because it is on an average basis we are getting fixed amount of fresh water annually. So you have to manage out of that. So that is why this improved water management practices is must. Suppose at present we are, as you know that at present we are using about more than 80% of fresh water in agriculture. But if per capita water availability is reducing day by day, so at some moment of time you have to fix priority. If it is in less, if availability become lesser per capita, so you have to fix proper priority, that what should be priority for water utilization. So this national water policy 2002 for water allocation is given this kind of priority. So if there is lesser availability of fresh water, so first we will meet the requirement of drinking water. Then only we will allow to use this water to the irrigation. So this is the priority. So suppose if any time this problem will come that fresh water availability is less in quantity, so there may be chances that due to this priority, first priority to drinking water, the availability for utilization of fresh water in agriculture or for irrigation is reduced. So that way also we have to be very careful that this irrigation or agriculture is not first priority. It is second priority after the drinking water. I have said, and from this presentation it is clear that okay, at present whatever is available, it is sufficient to meet our requirement. Okay, but it is on average basis. And I have told you that whatever fresh water we are getting this fresh water due to precipitation, and our average precipitation is about 1160 millimeter. So that is okay, but it is not uniform distributed. This rainfall is not uniformly distributed over the entire country. So that is also a concern. On average basis, it is looking that okay, we are meeting our requirement. But if you see the distribution of rainfall, spatial distribution of rainfall, so our average annual rainfall is 1170 millimeter. But it is for entire country. But if you talk about average annual rainfall in center of the country, in the center, so it is around 1100 millimeter. And if you talk about average annual rainfall in northeast region, it is 11,000, more than 11,000 millimeter. And if you talk the rainfall or precipitation which we are getting in western part, Rajasthan, so it is around 150 millimeter. So there is huge variation. In some of the regions, we are getting heavy rainfall, and in some of the region, we are getting very less rainfall. So that is the main problem. We are estimating all those things on an average basis. But at average, how it is differ from place to place, it reflects from average annual rainfall of the country and maximum average annual rainfall our country for in certain region and minimum average annual rainfall in certain region. It is varying from 150 millimeter to 11,690 millimeter. So this is huge variation. Another thing regarding rainfall is temporal variation. You all are aware that maximum rainfall, maximum precipitation which we are getting in monsoon season. So maximum we are getting in monsoon season, and in other seasons we are getting less amount of rainfall. It is not uniformly distributed throughout the year. It is concentrated in monsoon season. So these are the two things which cause worry to regarding availability of water, and we have to have some good management practices so that this problem can be addressed. So where is scope? I have told you that this freshwater availability on an average basis is fixed. So it is not going to change. You can reduce some of the losses through evaporation, some runoff. So you can get some additional water for utilization. So here is a scope. If you talk about per capita storage, so we are storing a very less quantity of water per capita. And there is scope for storage, because you have seen that out of 400 million hectare meter, there is huge amount of water is going to be placed as a runoff. So that runoff can be captured and put under storage. So this figure can be increased from 262 cubic meter per capita storage, we can increase. So here is scope. There is a scope of water harvesting, and we can store some more water, and that can be utilized for different purposes. So by water harvesting or some other kind of enhancement in water storage, we can manage this problem of water availability. Another part is that we can reduce the requirement of irrigation water requirement by enhancing the irrigation efficiency. Here you can see that overall irrigation efficiency in India is about 38%. So there is scope. Here is scope. We can enhance this overall irrigation efficiency. And for that, we have to use different advanced techniques for irrigation, so that this overall irrigation efficiency is enhanced. So here, these are the figures for water use efficiency in Indus and Ganga river systems. And here you can see that the area which is under the area which depend on groundwater, so their irrigation efficiency is more. But we have already seen that in certain region there is problem of over exploitation of groundwater. So you have to think that the proper groundwater recharge should be there, so that we can use that groundwater for agriculture. So the problem of freshwater availability can be reduced by increasing the storage capacity and by enhancing the irrigation efficiency. And for that, you have to use some improved irrigation methods. And you all are aware that this drip or sprinklers or micro irrigation are efficient methods. So by using these methods, we can increase the irrigation efficiency, and we can save a lot of fresh water which can be utilized in other sectors. When you talk about sprinkler or micro irrigation or drip irrigation, So it is just for comparison. We have used this data. And you see that around 2010, we are using only in 8% of area is under drip and sprinkler. But in other country, we can see here that in USA, it is more than 50%. In Russia, it is more than 50%. Brazil, more than 50%. Spain is around 70%. Italy, more than 50%. France, more than 50%. South Africa, more than 70%. Saudi Arabia, more than 50%. But in India, it was only 8%. So there is scope that we can enhance the area under drip and sprinkler irrigation. There is a lot of scope for enhancing the area under drip and sprinkler, because in many countries it is more than 50% area is under drip and sprinkler. So here in our country also, we can increase area under drip and sprinkler. So there is a scope. And one of the committee which is recommended that in our country, in India, this much area is suitable for drip and sprinkler based on cropping pattern. They have considered the cropping pattern of entire country, and on the basis of that cropping pattern, they have found out that this much area can be brought under drip and sprinkler. Because you know that drip irrigation cannot be used in every crop. So drip irrigation is suitable for on the basis of suitability of drip irrigation for particular crop. They have identified that this much area which is growing the crop which is suitable for drip irrigation system, so that can be brought under drip irrigation system or can be brought under sprinkler irrigation system. So they have found out that about 27 million hectare can be brought under drip irrigation system. Similarly, 42 million hectare can be brought under sprinkler irrigation system. So in total, about 70 million hectare can be brought under drip and sprinkler irrigation system. At present, you know that it is very, very less than this figure. So we can go up to that. Of course, it will require huge amount of expenditure, but step by step, we can brought this much area under drip and sprinkler, and we can solve this fresh water availability issue up to some extent by using these advanced irrigation systems or methods. Here I have showing this source of irrigation. Only I am showing this because of that to show you that how much area is under tube well or well irrigation. So it is better to use more drip and sprinkler irrigation system in these areas, because we are already lifting irrigation water from well or tube wells. So it become easy to use drip and sprinkler in this region. So first we can go in, you can popularize drip and sprinkler in these areas where tube wells or wells are used for irrigation water. So I have talked about we can solve this issue up to some extent by enhancing the irrigation efficiency. And we can see here that irrigation efficiency we can increase by using the different methods of irrigation. And of course, we can get highest irrigation efficiency in case of drip irrigation. So if we are using drip irrigation system, certainly we are going to save a lot of irrigation water, and at the same time we are also going to save the nutrients because of this enhancement in irrigation efficiency. This is the drip irrigation system, you all are aware. But my purpose to show this figure that there is a lot of components of drip irrigation system. There is one component that is venturi. So by using this venturi, or you can say fertigation unit, you can save a lot of nutrients which are used in agriculture. So if you are not using this venturi or fertigation unit in drip irrigation system, so by using this methods, you will get only partial benefit of drip irrigation system or micro irrigation system. But by using this venturi or fertigation unit, if you are using that component in your drip irrigation system, so by using this, you can save water, irrigation water, as well as you can save nutrients. So only thing is that whenever you go for drip irrigation system, you should also include this component so that you can save the nutrients and chemicals which are used in agriculture. So only thing is that why we are saving so much irrigation water. This drip irrigation is very simple. I always encourage that you don't go for a very complex drip irrigation system in first step. You use some simple type of drip irrigation system. You use simply one lateral line in your kitchen garden or nearby area, and you see that how much irrigation water you are going to save. Then you go for a full-fledged drip irrigation system in your field or in your farm. Sorry. So by seeing this figure, you can imagine that how much irrigation water you can save for through drip irrigation system. And this is the wetting pattern in case of surface drip irrigation system, and this is wetting bulb in case of subsurface drip irrigation system. And anyone can use drip irrigation system by simply getting this lateral pipe and putting this dripper on the lateral by using this punch. So first you try to use one lateral like this in your kitchen garden or in your nearby area. And if you convince that, okay, this irrigation system is very much suitable for this particular crop, and it is also useful in saving irrigation water, and as well as we are also getting higher yield, so you can go for larger scale. So as I have told you that we cannot go for entire area for drip irrigation system. Uh, One reason is that this drip irrigation system is costly one, and it may not be economical in very many crops. So these are the crops where we can go for a drip irrigation system or micro irrigation systems. So a lot of crops which can be grown under drip irrigation system. And if you talk about water saving, so here you can see that more than 30% water can be saved, or even in some cases, it is about 60% irrigation water can be saved. And at the same time, we are also getting some more yield by using this drip irrigation system. So drip irrigation system, by using this drip irrigation system, we are saving water, we are saving nutrients, and at the same time, we can get some higher percentage of yield also. So here we can see that these areas between rows of crops is left as dry. So because of that, there may not be growth of weed growth, and we can move in the field very easily. In some of the crops, vegetable crops, we have to miss regular picking will be there for 1 month, 2 months. So this, since this area is dry, so we can enter in the field very easily, and we can take care of these plants, and at the harvesting stage, we can pick those produce on regular basis. There is no problem. And this, due to this dryness, there will be less chances of disease and pest attack in the field. And because of partial irrigation, we are using part of area. So due to this, we are saving a lot of water. So here we can say that this much area is only required irrigate at initial stage. So we are putting that much of water to the crop so that their requirement will be fulfilled. Rest of the area is dry. Otherwise, in other method of irrigation, we generally provide irrigation water to entire area. So that way, we are wasting our irrigation water. Here I have taken some photographs in this Sonbhadra region, and in month of May, you can see that in month of May in Sonbhadra region, temperature is very high. But many farmers now cultivating vegetable crops and using drip irrigation system. So in very high temperature, it is not possible to cultivate these vegetable crops, and because of this drip irrigation system, they are able to cultivate these vegetable crops in this region. Here we can see that this is the field of vegetable crops, and it is growing very well in summer season. And it may not be possible, I think, if drip irrigation is not used in that area, because there is also shortage of water and temperature is very, very high in summer season. Here they are also using drip irrigation, and in these channels they are growing this coriander leaves, and in summer season they are getting good amount of means they are generating good remuneration through this selling this coriander leaf. So that way means the productivity of land is very, very high, and they are throughout a year they are getting crop from their field. So these are the some of the field farmers which are using drip irrigation system in Sonbhadra region, and they are generating good income. You can imagine in month of May, these are the seedlings of cauliflower. So in that high temperature also they are managing to grow this crop in that region. These are some greenhouses in that region. Some of the farmers are growing flowers in greenhouse. So it means there is problem of availability of fresh water, and this problem, this issue partially can be solved by storing more and more water, more and more rainfall or runoff water, and by enhancing the irrigation efficiency. Let us talk about nutrient management. So here, this is shown that if you are using surface method of irrigation, so we are using different kind of chemical fertilizers for different kind of nutrients. So there may be chances that some of the chemicals will move beyond the root zone, and some of the chemicals or some of the nutrients will remain on the ground surface or near the ground surface in case of surface method of irrigation. But if you use drip irrigation with fertigation system, so there is chances that there will be uniform distribution of nutrients in the root zone. And by using this drip irrigation or drip fertigation, we can enhance the fertilizer use efficiency. If in case of, there is soil application, so in case of nitrogen, its efficiency is 30 to 50% only, but it can be enhanced up to 95% in case of fertigation system. Similarly, it can be doubled in case of phosphorus. In potassium also, it can be enhanced from 50 to 80. So this kind of enhancement in fertilizer use efficiency we can achieve through using the drip irrigation system or drip fertigation system. So this way we can save a lot of nutrients also. And one more thing, that in in India we are second largest consumer of fertilizer in the world, but after China. But we are not producing so much of nutrients or so much of chemical fertilizers. So by 2020, fertilizer demand in the country is projected to increase to about 41.6 million tons, 23 million tons of nitrogen and 11.5 million tons of potassium and 7.5 million tons of K. So this kind of projection is, this kind of requirement is there, but we are not producing so much. So we are dependent on other countries. Here we can say that the indigenous fertilizer production from 2009 to 10 to is almost at the same level. It was almost same. Means we are not increasing our production capacity at the rate of the growth we are seeing in consumption. So that way, the option is that we have to use techniques of irrigation, techniques of crop management, which can save the nutrient. So with the help of drip irrigation system or fertigation system, we can save a lot of fertilizer. And here we can see that these are the crops, and 20 to 60% saving in fertilizer we are achieving, and at the same time we are also increasing the yield of the crop. So there is increase in yield, there is increase in production with the saving in fertilizer. So this way, by using the drip or sprinkler or micro sprinkler, we can save a lot of water and lot of fertilizers. And there is a lot of scope. There is a scope. There is a larger area is under well and tube well irrigation. We have only achieved up to 8% area, irrigated area is converted into drip and sprinkler irrigation system. So there is a lot of scope. And there is a lot of potential area for drip irrigation system. So by using drip irrigation system, we can save a lot of fresh water and nutrients. So that was the aim of this presentation. We can also save a lot of water through other techniques like laser leveler techniques or other. I'm not going into that because our time is over. So these are using these techniques also you can reduce irrigation water. So thank you very much for your patience hearing. If you have any query, any suggestions, you are most welcome. Please. If anyone have any suggestions, any query? Okay. Thank you.
Thank you so much, sir. Sir, let me unmute the participants. Participants, if you have any questions, please ask the sir. You can ask the questions now. Participants, any questions? Any questions?
Participants, please ask questions. Actually, Professor Ram Mandir Singh sir is a very renowned person of Banaras Hill University. He is, as you find in his lecture, he delivered many things, and this definitely will be helpful to doubling farmers' income. So, I again requesting you, please ask your queries.
Uh, I think there are no
Hello.
questions. Okay, please,
Hello.
Amit, ask.
Amit
Yes, yes,
Biswas is asking something. Please.
yes. Good afternoon, sir. I'm from West Bengal. Now I'm working as an professor in agriculture department from the Institute of Technology, West Bengal. It is the new subject in the Institute of Technology.